on VLSI YouTube channel. In this video, we are going to discuss about conversions. Conversions is a broader area which has multiple procedures. Binary to decimal, decimal to octal, octal to base 7 number system, base 3 number system to base 6 number system. But don't worry, we will teach you a two-step procedure through which you can convert any one number system to another number system. Say, for example, 236 base 7. I want to convert this to base 4 number system. How you can do it? No need to remember the procedures, the direct procedure which will convert base 7 to base 4. The two-step procedure is, first, what we want to do is, in step 1, we will convert this any one particular number system to decimal. Say, any system to decimal. Got it? And then, after conversion of decimal, you can convert the decimal number to that base 4 number system. So, decimal to base 4 number system. That's it. If you remember these two steps, so you can convert any one number system to another number system. First, let's see step 1. Any system to decimal. Let's see this question. Which one of the following is the correct sequence of the numbers represented in the series given below? 2 base 3, 1 0 base 4, 1 1 base 5, 1 4 base 6, 2 2 base 7. They are in decimal. 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 2, 4, 6, 10, 12, 2, 4, 6, 10, 16. This question is all about how you can convert a particular number system to decimal. The procedure is, guys, let us take one particular number, PQ dot RS. This is a particular number system, say small r. Then how you can convert this into decimal? You need to multiply with its positional weightage and we need to add it. That means this is a dot, right? From here you should come in this way, or for this RS you should go like this. Means it is like P into the positional weightage is R power 1. This is R power 0, this is R power 1. So R power 1. Similarly, Q into R power 0 plus here dot. And then here it is after the decimal point, right? Now here it is minus 1, it is minus 2. Means R into R power minus 1 plus S into R power minus 2. That's it. So here with their positional weightages we need to multiply and finally we want to add. That's it. That is only the procedure to convert any number system to decimal. In this way, let us take 2. What is the procedure, guys? Here only one digit is there. Therefore, you can say 2 into 3 power 0. Anything power 0 is 1 only. 2 into 1, 2. Next, 1 0. So that 1 into 4 power 1 plus 0 into 4 power 0. Now what it is? 4 only. Similarly, 1 1 means 1 into 5 power 1 plus 1 into 5 power 0. What is that? Guys, 5. So anything power 0 is 1. So that it is 6. Similarly, 1 4. 1 into 6 power 1 plus 4 into 6 power 0. That is 10 only. Similarly, 2 into 7 power 1 plus 2 into 7 power 0. That is 7 2s are 14. 14 plus 2. 16. This way. So guys, here the sequence in decimal form is none other than option D. 2, 4, 6, 10, 16. Okay? Let's see another example. If x and y are two decimal digits and 0.1101 base 2 is equals to 0.8 xy 5 base 10. The decimal value of x plus y is. Guys, this question is all about conversion of binary to decimal. Yes. Now, how to convert any system to decimal? We need to multiply with its positional weightage as per the radix value. So, the value is 0.1101. So that here this is base 2, right? So this will be 2 power minus 1 weightage, 2 power minus 2, 2 power minus 3, 2 power minus 4. So here point 1 into 2 power minus 1 plus 1 into 2 power minus 2 plus 0 into 2 power minus 3 plus 1 into 2 power minus 4. Okay, this is the one. Now here, what is 2 power minus 1? 1 by 2, 0.5. 1 into 0.5, 0.5 plus 1 into 2 power minus 2. Guys, 2 power minus 2 can be written as 1 by 2 power 2. That is 1 by 4, which is 0.25. So 0.25 into 1, 0.25. Similarly, here it is 0 into 0 into everything is 0, 0 plus again 0 into 1 into 2 power minus 4, it is 0.0625. Now we want to add all of them. Therefore, here if you add, we will get 0.8125 base 10. This is the decimal value. Now you compare with this 0.xy, 8xy 5 base 10, 0.8125 base 10. So that x value will be 1, y value will be 2. Now x plus y is 1 plus 2 is 3. So guys, here the right answer is 3. Let's see another example. If 4310 base x is equals to 580 base 10, then the value of x is, guys, the RH is in the decimal number system and the LHS has the base value x and we want to find out now x. So it's easy, guys. Here if you want to calculate this x, you just convert into decimal this number. Therefore LHS and RHS both are in decimal, so that you can calculate x value. That's it. So what is the procedure to convert any system to decimal? You need to multiply with their positional weightages and finally you need to add. That's it. So here this can be written as 4x cube because this is 0, 1, 2, 3. So that 4 into x cube plus 3x square plus x, that's it, is equals to 580. Now the equations are in decimal. Yes. Now coming to the point, we want to find out x. There is one way. You need to find out for this equation the roots so that you can get the value. But that approach may be time consuming. What I am suggesting you is there are options. Why don't you try the options? Isn't it? For example, let us consider option C where x is equals to 8. If x is equals to 8, what might be the total value? Let us consider 4x cube. 8 cube, 512. 512 into 4, nearly 2048. If itself is the 2048, then how it will be equal to 580? Not possible. Hence, x is equals to 8 is not the correct option. It is around 2048, right? Then x is equals to is not at all 8 or 7. Let's try 5. X is equals to 5. If x is equals to 5, then 4 into 5 cube plus 3 into 5 square plus, that is 5, is equals to 580. Now you try here. This is 5 cube 125. 125 into 4 500 plus 5 square 25. 25 into 3 75 and plus 5 is equals to 580 only. Therefore, we can say whenever x is equals to 5, LHS is equals to RHS. So instead of calculating the roots running behind the expressions whose values are q power 4, it's better to try from the options. Okay, so as per the question, the right answer is x is equals to 5, option B. Okay. Now guys, it is step 2. Till now we understand how to convert any number system to decimal. Now it's time to learn how to convert a decimal number into any number system. This is step 2. Got it? Now let's have the question. The representation of the decimal number 27.625 base 10 in base 2 number system is, means here the question tells us how you can convert the decimal number system to base 2. What is another name of base 2 number system? Binary. Right? Now the procedure is like this is integer part and this is fractional part. We need to divide the integer part and we need to multiply the fractional part with the radix value. Okay, so to which number system you are going? Base 2. The radix value is 2. So with that 2, you need to divide the integer part. Right? Now let's divide the integer part. 27. If you divide with 2, 2 ones are 2 3s are. What is the remainder? 1. Similarly, 2 6s are. Remainder is 1. 2 3s are. Remainder is 0. 2 1s are. Remainder is 1. And here we need to go from bottom to top. So the integer part in binary is 1 1 0 1 1. That's it. You have divided the integer with the radix value. Done. Now it is fractional part. You need to multiply the fractional part. Means 0.625 into 2. So this 2 value is radix value. Suppose if the radix value is, let's assume 9. You need to divide with 9. You need to multiply with 9, the fractional part. Okay? Now, let's see. What is the value? 2 5s are 10, 2 2s are 4, 5, 2 6s are 12. Okay? So, 3 decimal places, it's 1. So, here the integer value is 1. You can write separately 1. Similarly, here 0.250 into 2. Then it is 0, 2 5s are 10, 2 2s are 4, 5. It's 0 point. So it's a 0. Now again 0.500 into 2. Then we will get 1,000. It is 1. And here in integer we went from bottom to top. But here you need to come down from top to bottom. Okay? Therefore, it is 0.101. This is the procedure. Remember, while doing the multiplications, remember, you will get zeros, 0.000. Then you can't do it. You can stop over there. Or else for the VLSI placements or any like interviews or whatever, like in this VLSI placements line or even competitive exams also, you can do 3 or 4. That is more than sufficient. Or else you can see from the options. Options after the decimal point, 3 binary bits like digits are there, bits are there. So you can start here 3 like that. And here remember again I am telling you, you need to separate the integer, whatever it might be. And the remaining, like after the integer, whatever the value, that only you should take. Remember, it's 1.250. One here I kept it, and here I have written 0.250 only. It could be 1, it could be 10, it could be 8 or it could be 7, whatever. It could be any number. You need to separately write the integer part and then you need to continue with the fractional value. That's it. Okay? So, now, what is the right answer? Here it is a 11011.101. Hence, 11011.101. Option C is the right answer. Here is the another example. Octal code of decimal number 27 would be 27332372. Guys, here we want to find out the octal code from the decimal number. That means it's decimal to any system only. The procedure is we need to divide with the we need to divide the integer part with the radix value. We need to multiply the fractional part with the radix value. Of course, here we don't have any fractional value, we have only integer. So let's continue. It is 27. We need to divide the integer part with the radix value. What is the radix value of octal? 8. So 8 3s are 24. The remainder is 3. The procedure is like from bottom to top. Then it is 3 3 base 8. So guys, the right answer is option B, 3 3. Again I am telling you, it is 3 3, not 33. 33 23 is decimal. Why are you taking that one into the octal? You should say 3 3 only. Okay? Now let's see the question. Here, if 432 base 5 is equals to x base 7, then the value of x is, the LHS is in base 5 number system. RHS is in base 7 number system. So this question tells us how can you convert base 5 to base 7. We have been discussing for any number system to another number system. You just follow two-step procedure. Step 1, any system to decimal. In this case, base 5 to decimal. And then decimal to any system, decimal to base 7 system. That's it. If you remember the two-step procedure, therefore you can go from one number system to another number system. That's it. Let us start. Here 432. First we convert any system to decimal. This is a two-step procedure, the first one. Okay, what is the procedure, guys? Just we need to multiply with their positional weightage and finally you need to add. That's it. So it is 4 3 2. It is like 5 power 0, 5 power 1, 5 power 2. Therefore 4 into 5 power 2 plus 3 into 5 power 1 plus 2 into 5 power 0. That's it. Then 5 square, 25. 25 into 4, 100 plus 15 plus 2, it is 117 base 10. So 117 base 10. Now what is the next step? We need to convert this decimal into base 7 number system. Let's have here step 2. decimal to any system. In this case, it is base 7. Let's try. What is the procedure? Simply, you need to divide the integer, multiply the fractional part. That's it. With the radix value 7. Here, it contains only integer part. Therefore, you just divide. That is 117 base, like it's 7. 7 ones are 7. 4, 47, 6 7 6 jars, 42, it's 5. Similarly, 7 2 jars, 14, remainder is 2 from bottom to top. Then it is 225 base 7. That's it. So that's it for any number system to any number system. By using this two-step procedure, you can do easily. And from this, guys, you can observe one point. What is that? Here, let us write here the number. What is that? 432 base 5 is equals to 225 base 7. The lower radix value has higher number. The higher radix value has lower number. That means if P is P base R1 is equals to Q base R2, if it is equal, here we can identify one point, that is, if P greater than Q, then definitely R1 less than R2. That's it. The higher value has lower radix number. You can see this one. In this way, at least you can guess from the options. Okay, guys, this is about like any system to any system conversion by using two steps procedure. That's it, guys. If you like the video, please subscribe our YouTube channel and press the bell icon so that whenever we upload the video, you will get notification instantly. See you soon in the next video. This is Shivaram signing off. Jai Hind.